This week on Pale Blue Dot Narrative, we're diving into 3 powerful stories that stretch across the spectrum of science and technology, from the microscale precision of robotic swarms to the vast expanse of deep space, with a stark look at our own planet in between. First, imagine a swarm of tiny robots that can flow like a liquid, then suddenly solidify to push or carry an object. Scientists are now building biologically inspired machines that blur the boundary between fluid and solid, just like schools of fish or flocks of birds. These shape-shifting swarms are more than just engineering marvels. They represent a leap forward in robotics that could transform everything from disaster response to targeted medicine. It's a glimpse into a future where machines adapt like living systems. But while we push the boundaries of what machines can do, our natural world is under increasing strain. New data shows that in 2024, global primary forest loss has surged to an all-time high, doubling previous rates. These are the Earth's most pristine ecosystems, and their destruction is accelerating. This isn't just about trees, it's about biodiversity collapse, carbon emissions, and the unraveling of planetary systems we depend on. The consequences are immediate, and they're global. And finally, we turn our gaze upward. NASA's Habitable Worlds Observatory is on the horizon, and it could redefine how we search for life beyond Earth. This next-generation space telescope will be capable of spotting Earth-like planets orbiting distant stars, analyzing their atmospheres for signs of habitability, or even biosignatures. It's one of humanity's boldest steps yet in the quest to answer an ancient question: are we alone? From shape-shifting robots to vanishing forests to the hunt for other Earths, this week's stories remind us just how quickly the lines between science fiction and reality are fading, and how much is at stake, both here and far beyond our pale blue dot. Let's dive in! In the first segment, Tech Threads, where we explore the fascinating world of technology, we're diving into one of the most mind-bending developments in science and technology. Imagine a world where robots don't just move and work independently. They flow together, morph, and heal, just like living tissues. That's exactly what researchers from UC Santa Barbara and TU Dresden have brought to life with their latest breakthrough, a swarm of modular, bio-inspired robots that can seamlessly shift between solid and fluid states. Let's break down how these robots work. Each unit is disc-shaped, about the size of a hockey puck, and packed with advanced features. Around the perimeter, 8 small gears give each robot the ability to move and rotate with precision. Glowing sensors dot the surface, detecting light and helping the robots navigate their environment. Embedded magnets allow them to connect and disconnect with ease, forming dynamic, shape-shifting collectives. But the real magic lies in how these robots behave together. Inspired by the adaptability and resilience of embryonic tissues, where cells reorganize, heal, and adjust their collective strength, this robotic swarm can self-assemble, adapt to obstacles, and even repair itself. Imagine watching these robots flow like liquid around barriers, then lock together to form a solid pillar strong enough to support a human. In experiments, the swarm has already demonstrated this remarkable capability, holding hundreds of times its own weight before reverting back to a flowing state. The system operates through decentralized control. Each robot makes decisions based on local interactions rather than following a central command. This allows the swarm to exhibit emergent behaviors, self-assembly, self-healing, and dynamic reshaping, that mirror those seen in living organisms. The potential applications are as exciting as the technology itself. In disaster response, these robots could navigate through rubble, forming bridges or supports on the fly. In medicine, miniaturized versions might assist in surgeries, deliver drugs, or even act as temporary scaffolds for tissue regeneration. Space exploration could see modular robots assembling and repairing structures in orbit, adapting to changing mission needs. Even adaptive construction could be revolutionized, with buildings that reconfigure themselves in response to environmental shifts or new requirements. This breakthrough is more than just a step forward in robotics. It's a fusion of material science, bioengineering, and artificial intelligence. By mimicking the adaptability of living tissues, these robotic collectives open up new frontiers. As the technology matures, we may soon see structures and devices that can heal, adapt, and reshape themselves, ushering in a new era of smart, living materials. The future of robotics is not just about machines that move. It's about machines that live, learn, and transform. In this segment, Eco Insights, where we uncover the science behind the natural world and their impact on our planet. Welcome, listeners, to a critical discussion about the state of our planet's most vital ecosystems. Today, we confront a truly alarming development: the unprecedented surge in global primary forest loss during 2024. The numbers are stark, the implications profound, and the urgency undeniable. New data reveals a staggering reality. The destruction of primary forests, the ancient, irreplaceable lungs of our Earth, doubled in 2024 compared to previous years. Imagine this. In tropical regions alone, an area the size of Panama vanished at the astonishing rate of 18 soccer fields every single minute. This isn't just a statistic. It's a catastrophe unfolding, marking the highest level of primary forest loss on record. And the consequences? They reverberate across the globe. Forests are massive carbon sinks, soaking up enormous quantities of carbon dioxide. But when they're destroyed, that stored carbon is released, unleashing a torrent of greenhouse gases. The primary forest loss in 2024 alone is estimated to have unleashed 3.1 gigatons of greenhouse gas emissions. That's more than 4 times the emissions from all global air travel in 2023. This directly sabotages our efforts to combat climate change, leaving us catastrophically off track from commitments like the Glasgow Leaders Declaration. So, what's driving this relentless destruction? It's a complex and deadly confluence of factors. For the first time on record, fire emerged as the primary culprit, accounting for nearly 50% of all destruction. Climate-related factors, specifically the intensifying El Niño phenomenon, played a huge role, bringing unprecedented heat and drought. We saw this starkly in Latin America, where Brazil and Bolivia bore the brunt, with fires fueled by Brazil's worst drought on record. But let's be clear, most of the fires we see in tropical forests are human-caused. They're deliberately set to clear land for agriculture, for vast plantations of soy, for cattle ranching. Practices like saqueos, traditional slash-and-burn methods, become uncontrollable infernos when combined with extreme drought. And it's not just fire. Non-fire-related forest loss also surged, still driven by agricultural expansion, illegal mining, and new infrastructure development. It feels overwhelming, doesn't it? But there is a crucial element of this story that offers a glimmer of hope: technology. Against this backdrop of destruction, innovation is stepping up as a critical tool in the global fight against forest loss. Advances in remote sensing, artificial intelligence, drones, and mobile applications are revolutionizing how we detect, prevent, and ultimately mitigate deforestation. Think about satellite monitoring and AI. What used to be a tool for looking back is now providing near real-time data on forest cover changes. AI analyzes vast amounts of imagery, rapidly identifying illegal logging, clear-cutting, and even new road construction. Synthetic aperture radar can pierce through cloud cover and darkness for continuous monitoring. AI algorithms are even being trained to predict areas at high risk of fire, allowing for proactive interventions. Drones are becoming invaluable guardians, surveying vast remote areas, spotting small-scale illegal activities, and precisely assessing fire damage. They're even aiding in reforestation efforts. And then there are the mobile tools, empowering the very communities and indigenous peoples on the front lines. Apps allow them to report suspicious activities and share real-time information. Organizations like Rainforest Connection use solar-powered acoustic sensors, guardians, in the forest canopy, which, integrated with AI, can detect the sounds of chainsaws and send immediate alerts to rangers. All of these technologies are feeding into platforms like Global Forest Watch, providing comprehensive, publicly accessible data. This transparency is crucial for accountability and for informing effective conservation strategies. Yet, while technology offers powerful solutions, its full potential can only be realized through sustained political will, through stronger enforcement of environmental laws, and through a global commitment to address the underlying socioeconomic drivers of deforestation. The record-breaking forest loss in 2024 isn't just a statistic. It's a global red alert. It's a stark reminder that the time for decisive action to protect our irreplaceable primary forests is not tomorrow, but right now. Without them, the fight against climate change is a battle we are quite simply destined to lose. The health of our planet, and indeed our own future, hangs in the balance. In the last segment, Cosmic Conversation, we're going to talk about a future that feels very much like science fiction, but is rapidly becoming reality. Humanity's most ambitious quest to answer that timeless question: are we truly alone in the vast universe? We're talking about the Habitable Worlds Observatory, or HWO. This isn't just another telescope. It's a dedicated instrument, a super Hubble, if you will, being developed by NASA. Its sole monumental purpose is to directly image and characterize Earth-like exoplanets orbiting distant stars, specifically looking for signs of life. The HWO concept officially surfaced from the National Academy's Pathways to Discovery in Astronomy and Astrophysics for the 2020's Decadal Survey, which delivered its recommendations in November of 2021. Following that, in January 2023, NASA officially embraced HWO as its next flagship astrophysics mission. While the earliest we expect to see it launch is in the early to mid-2040s, the planning and technological maturation are well underway. Now you might be thinking, don't we already have powerful telescopes like Hubble and Webb? And you'd be right. But the HWO is fundamentally different. The iconic Hubble Space Telescope has been our eye across the ultraviolet, visible, and near-infrared spectrum, offering stunning views of everything from our own solar system to the distant reaches of the cosmos. The James Webb Space Telescope, a marvel of engineering, is optimized for infrared light, allowing us to peer through cosmic dust to see the early universe and to analyze the atmospheres of exoplanets as they transit their host stars. However, here's the crucial distinction. Neither Hubble nor Webb were designed to directly photograph an Earth-sized planet, tiny and faint, next to the blinding glare of its parent star. That's where HWO comes in. It's engineered specifically for this incredible challenge. At the heart of HWO's mission lies a massive primary mirror, expected to be between 6 and 8 meters in diameter. This increased light-gathering power is absolutely essential to collect enough light from these incredibly dim, distant worlds. Crucially, HWO will employ advanced coronagraphs. Imagine trying to spot a firefly next to a lighthouse from miles away. A coronagraph is a sophisticated instrument that acts like a precise shield, blocking out the intense starlight, allowing the faint reflected light from the orbiting exoplanet to become visible. Once that light is captured, HWO will use sophisticated reflectance spectroscopy to dissect it, looking for chemical markers, known as biosignatures, things like oxygen, methane, or water vapor, which could signal the presence of life. While its primary focus is undeniably the search for life, HWO isn't a one-trick pony. It will also be a formidable tool for general astrophysics, contributing to our understanding of how galaxies grow, the origins and distribution of elements across the universe, and even detailed studies of icy moons within our own solar system that might harbor subsurface oceans. The journey to HWO's launch is a marathon, not a sprint. It demands unprecedented advancements in ultra-precise optics, wavefront control, and even in-space robotic servicing capabilities, given its distant operational orbit. NASA has already established the Habitable Worlds Observatory technology, Maturation Project Office, or HTMPO, at Goddard Space Flight Center to accelerate these crucial technological developments. As the scientific community prepares for key gatherings, the excitement is truly palpable. The Habitable Worlds Observatory promises to usher in a new era of discovery, offering the tangible possibility of finally answering that most fundamental question: are we alone? That wraps up this week's journey on Pale Blue Dot Narrative. Thank you for joining us as we explored the latest breakthroughs at the edge of science and technology. If you enjoyed today's episode, be sure to subscribe and share Pale Blue Dot Narrative with fellow curious minds. Your support helps us continue shining a light on the wonders of our universe. Until next time, keep asking questions, stay inspired, and never stop exploring our extraordinary pale blue dot.